So it's AP Calculus AB. This is the 2000 release question number 6 from the AP test. Consider the differential equation that you see here. Find a solution to this that satisfies having the ordered pair 0, 1/2. In the notes and the homework, we said find a particular solution. This just says find a solution. It means the same thing. We need to separate our variables. Then we are going to integrate. To separate our variables, we're going to multiply both sides by our denominators. It's going to give us e to the 2y dy equals 3x squared dx. We are then going to integrate. Right side's pretty simple to integrate. That's going to be x cubed plus your arbitrary constant. The left side, not as simple. Let's set u equal to 2y. That's going to make du over dy equal to 2. It's going to make du equal to 2 dy. So dy is equal to 1/2 du. So if I replace the 2y with u as promised, and I replaced the dy with 1/2 du, I could put that 1/2 out in the front, and then we're just integrating e to the u, which of course is e to the u. U is 2y. So that's a 1/2 e to the 2y equals x cubed plus c. If I then take my, boy, I'm writing super big right now. If I then take the ordered pair that I was given, which is 0, 1/2, and I put 1/2 in for y and a 0 in for x, I'm going to get 1/2 e to the first equals c. Once I know what c is, I try to find my particular solution. To do that, I need to get y by itself. I'm going to multiply every term by 2 in an effort to try to get y by itself. Then I would, so currently this is in currently this is in exponential form. I'm going to change it to log form. The whole point of logarithms is to solve equations in which the variable is in the exponent. So in log form, this would be log base e, which we would write as natural log, of the argument, which would be 2x cubed plus e, equals the exponent of 2y. To get y by itself, multiply both sides by 1/2, and I get 1/2 of natural log 2x cubed plus e. So in conclusion, f of x is going to be 1/2 natural log of 2x cubed plus e. Now, how do you get points for this problem? Let me tell you how you get points for this problem. You would get 1 point if you separated your variables. You would get 1 point if you integrated the left side correctly and the right side correctly. You get 1 point if you put plus c. There's 4 points right there. You get a point if you found the arbitrary constant. That's 5 points. Then you got a point if you got f of x by itself correctly. It's a total of 6 points for that problem. Part B, find the domain and range of the function that you found in part A. Well, to be clear, that function is this function. That's not absolute value. My apologies. Well, as far as the domain is concerned, the argument of a logarithm I don't know if there's an E in here or not. I am sorry, I'm not very good at spelling. The argument has to be bigger than 0. The argument is 2x squared, 2x cubed plus E. If we solve this for x, we're going to get x has to be bigger than the cubed root of negative E over 2. So to be clear, the domain is going to go from the cubed root of negative E over 2 to infinity. You would get a point if you set the argument bigger than 0, and you get a point if you successfully found the domain. As far as the range goes, this is just going to go from negative infinity to infinity. You get a point if you say that. Let me explain how I know that. This is not part of your work, but any logarithmic function is going to have a vertical asymptote someplace, depends on the problem. The parent graph has it at x equals 0, and it's going to go down and up forever. That's how all logarithmic functions are. All of their ranges are negative infinity to infinity. So that concludes that problem's worth 9 points total, and that's how the points are dished out. That was 2000, question number 6.